Earlier we saw that the parentheses are used for grouping things. They are also used for capturing, so they have two uses actually at the same time. As we saw that this expression will match either apple pie or banana pie, and the parentheses here limit the extent of this pipe, the OR part. But once the match was made here, so within this block, the value that was matched by this parenthesis, so either the word apple or the word banana in this case, will be copied into a variable called $1. It's $1 because this is the first pair of parentheses in this regular expression. If there were more, they would be counted $2, $3, and so on, and they are numbered by the opening of the parentheses. So that's what capturing is. A pair of parentheses. When a match is successful, it matches something, maybe it's empty but something, and that something that was matched will be copied into the variable $1. Before the match is completed, actually the regular expression engine is always saving whatever this matched so far into internal variables, and that's what we see here, how we can use them. So in this example we are trying to figure out whether in this string there are two characters, one after the other, that are the same. Here the two O's specifically. So we are looking for some character, and that is immediately followed by the same character, without knowing upfront what character is. And the way to do that is using these buffers, or they call it, some people call it buffers. They are sort of internal variables of the regular expressions. So here in the parentheses I have the dot. This dot can match any character. As the regular expression engine proceeds, it will try to match this dot with various parts of the string, and then save it into an internal variable called \1. Now, because we are using that \1 here, it means that the next thing that it needs to match is the content of \1, which was filled just here. So let's see how it works in reality. So at the beginning the dot will match the M, because that's just one character. M is saved in \1, so that's what is here. So the next character should be M, but it's not M. So the regular expression understands that the previous match wasn't correct. So it goes further and says, okay, let's have the dot match Y, and the Y gets into the \1, and the next character is checked whether it's Y, and it's not. So we go on, and the dot matches space, but the next character is not space, so it again fails. And then the dot tries L, and L gets into \1, and the next character is not L, so that fails too. And then the regular expression reaches the point where it matches the first O, and the O gets into the \1, so the next character must be O, and it is indeed O. So these two match already, and then we reach the end of the regular expression, meaning the regular expression was successful. So then we get into this block, and whatever was matched by the parentheses, so that's the O, specifically the first O, not that it really matter, but the O will get into $1. The content, what was in actually \1, will be copied into $1. So as you can see, it can be very powerful to match, because you can reuse part of your match in the leftover part of your match, in the second part of the match, of the regular expression. Here you can see a very basic example of trying to match a word twice. Now this is very far from being good and correct, but I wanted to show you something that can be already done with our current knowledge. So what's a word? Well, in our case, let's say the word is a character from the A to Z character class, so it's one of the lowercase letters, okay, plus meaning once or more. So this pair of parentheses would match any part of the string that's a bunch of lowercase letters. Beforehand there is a space, so the regular expression first needs to match a space, and then a word, so lowercase letters, then another space, then dot star means just any garbage. It just can capture any, it can just match any part of any string, well, except of new lines. Then again a space, the previous word, and the space again. So there's a problem here, because for example, even if this doesn't match anything, we require two spaces between the two appearances of the word. But this is just because we haven't learned all the parts that we need to build a nicer way to match two words one after the other, or just two words, just the same word twice. So this will match some string. So let's say the first beginning it will try to match the in, but it doesn't find any place where the in word between two spaces exists. So there is somewhere here a line, there is the in here, but it's not between two spaces, so this won't match. Then it will proceed and try to match this, and go on, and it will find at some point that there is the same word appearing here between two spaces, and that's it. So $1 will contain this. And this is just an example that usually I ask people to think about, so I'm going to do that. Here was the regular expression I sorted, quite similar to this one. So it would match dot plus matches just any string, one or more characters, and it captures. Then dot star captures anything between, and then \1 meaning find this thing again. So something twice, that's basically what it says. So I wanted to extend it, and I put parentheses around it and plus, so I can show you that I can put quantifiers also on groups. Yeah, that was what I wanted to show. And then I started to run this piece, and it gave me a syntax error. So just think about it why, and I'm sure you'll figure it out. The last example here is another slightly useful example, is when you have these inifile style something, inifile files that has lines with some key equal to some value, and you would like to parse this and take the key and the value, and here we assume that that there are no spaces around the equal sign. So how does it look? It says dot star, so any character, any any number of times, then an equal sign, and then again some more characters. So this explains that, describes those lines. And then the first part is the left hand side, which goes into $1, and the second part is the right hand side, which goes into $2, and then you can print them, and you can build a hash from these or whatever. In this expression within, you know that $1 contains the key and $2 contains the value.